So in this video, I want to analyze the concavity of this function. So we have the function we have is y is equal to x to the third minus 2x squared minus 3x plus 4. All right, so without doing anything mathematically, let's first just look at this graph and see what we know about the concavity. And let's see we can perhaps approximate some concavity. So again, what we know about concavity is that if concavity is up, or is concave up, then the second derivative has to be greater than 0. And what that means is that the rate of increase is increasing, or the rate of increase is positive, or the rate of decrease is also positive. So in this case, what this means is that the looks like the graph is concave up from somewhere around here. It starts being concave up, and all the way looks like to infinity it's going to be concave up. And then for negative infinity to, again, around here, seems like it's concave down, right? And I'd say this point is the inflection point, right? Where it turns from concave down to concave up. And that point is, I don't know, somewhere around maybe 0.6, 0.5, right? Somewhere around there. All right, so now let's do this mathematically, and let's see if our answer matches what we got here. So let's try to remember this function, x to the third minus 2x squared minus 3x plus 4. Okay, so I think I can remember that. So the function we had was f of x is equal to x to the third. Wait 1 second, the pen is not writing. All right, so the function we had was f of x is equal to x to the third minus 2x squared minus 3x plus 4, I believe. Let's double check really quickly. Yep. Okay. And we want to figure out where this graph is concave up and concave down mathematically. So let's write that out. So I'll do concave up on the left side. Well, what we know about concave up is the graph is concave up when the second derivative of the graph is greater than 0. So let's use that mathematically to figure out the x values for which the graph is concave up. So the first derivative is, well, 3x squared minus 4x minus 3, right? We use the power rule. Now, if we want to figure out the second derivative, we can just take the derivative of the first derivative. So the second derivative is the derivative of this, which is 6x minus 4. And for concave up, we want this to be greater than 0. All right, well, we can solve for x pretty easily in this equation right here. So we get 6x is greater than, we're going to add 4 on both sides. We get 6x is greater than 4. Divide by 6 on both sides. We get x is greater than 4 over 6, which means x is greater than 2 over 3. So our guess was actually pretty good. We said x has to be, the inflection point starts around 0.5, 0.6, right? And then it goes to infinity, right? So that means so it's concave, actually I'll write it up here. So it's concave up from 2/3 all the way to infinity. So our guess was actually pretty good. We said it's around 0.6 or so, right? And 2/3 is around 0.66 or 0.67. So this is when it's concave up. All right, now for concave down, our guess was that it's from negative infinity to, again, the inflection point. So we should already be able to write the answer here, but let's just do it with math, with second derivatives once again. So let's do a different color here. So we know that it's concave down. It's concave down when the second derivative of x is less than 0. All right, well, let's figure out the second derivative again. We already have it, but let's just do it again. So f prime of x, we know that it's 3x squared minus 4x minus 3. We can find the second derivative by taking the derivative of the first derivative. So this becomes 6x minus 4. And then we know that it has to be less than 0 for this to be concave down. So we have a simple equation we can solve, which is 6x minus 4 is less than 0. Add 4 on both sides, we get 6x is less than 4. Divide on 6 by both sides, we get x is less than 4 over 6, which implies that x is less than 2 over 3. And again, this is the guess that we made as well. We said it's a negative infinity to that inflection point. So it's concave down from negative infinity to 2/3, and that's what x is less than 2/3 means. So again, it's concave up from the inflection point, all the way to infinity, and then from negative infinity to the inflection point.